We are FTC Team 18459 Husky Robotics, and this is our Control Award submission. To start, let's take a look at our autonomous. At the beginning of the autonomous period, we utilized TensorFlow object detection, which allows the webcam attached to the robot to determine the number of rings in the starter stack. Based on this result, the robot will then carry out one of 3 different autonomous programs, each of them dropping off the wobble goal in a different target zone. In this particular video, there were 0 rings in the starter stack, which means the wobble goal should be dropped off in target zone A. The movement of the robot around the field during the autonomous period is arguably the most difficult part of FTC programming. So to make it quick and efficient for us, we utilized the Roadrunner path planning tool. Using Roadrunner, we can tell the robot exactly where to go in the field using XY coordinates, as well as do complex spline movements, which makes it much easier to do all the navigating around the field during autonomous. Okay, let's go over that again. We start our autonomous by moving to the shooting position and knocking over 3 power shots, earning us 45 points. We then proceed to drop the first wobble goal, which earns us 15 points, and then move towards the second one to pick it up. We then drop the second wobble goal, 15 points, and park on the launch line, 5 points, which results in a total 80-point autonomous. Moving on to driver controlled. In the driver controlled period, in order to make driving around the robot easier for the driver and to score higher, we automated the shooting process. We do this using Vuforia image detection. Using Vuforia, the webcam can detect the target images on the field perimeters and calculate the relative position of the robot to that image. Using this information, the robot can automatically navigate itself to a predefined shooting position and shoot 3 rings into the high goal. Using this technique makes Tele-op easier for the driver and allows us to shoot more cycles of 3 rings into the high goal. Speaking of Tele-op and driver controls during Tele-op, here are some of the controls we have used. For basic movements like strafing and turning, we use the left and right joysticks. We have also programmed the front triggers to slow down the robot movement speed so the driver can control the robot at their preferred speed. The driver can also switch between the front direction of the robot being the actual front of the robot or the direction of the wobble goal grabber, as our wobble goal grabber is on the side of the robot and it's more intuitive that way. Finally, we have 2 buttons on the front of the gamepad that determine the height of the wobble goal grabber, and 1 button that toggles between wobble goal grabber open and wobble goal grabber closed. Well, that's all for our Control Award submission video. Thanks for watching!